All right, we'll keep doing some more examples here. Okay. Okay. Now, let's see. We have a molecule which has two carbons attached like that. So let's see, what do we do with molecules like this? Again, look for the longest chain. It seems quite obvious here that the longest chain is 1, 2, 3, 4, 5, 6, 7, and 8. So the longest chain is 8 carbons long. And we can also tell that the numbering we have done, the blue numbering from left to the right, it actually should be correct because your substituent, the branch point, is at number 3. And it's closer to the left-hand side, much farther from the right-hand side. So the numbering must start from this side. Okay, so now, so again, the first rule was to find the longest chain, the parent chain, which we already did. The second rule is to look for a substituent. So circle your substituent and get their names right away. Okay, getting the name of the parent of the longest chain is easy here because the longest chain is 8 carbons. So 8 carbons, that must be octane. The point is, what is our substituent? Look for the substituent. Our substituent, we got, you see, this carbon here has a carbon here and a carbon here. Okay, so we got this carbon and we got this carbon. Okay, we got 2 carbons, but these 2 carbons are not like this. They're not 2 continuous carbons. These are 2 separate carbons. Okay, so those are 2 individual carbons. So this is one substituent and that is a different substituent, but both happen to be single carbon, single carbon. So guys, one carbon as a substituent is called meth. What is the suffix? YL. What about this guy? This guy is the same thing. This guy is also one carbon substituent, so methyl. So what do we have here, guys? We have 2 methyls which are sitting on our octane, right? So we got 2 of them. Okay, now, whenever that's the case, whenever you have 2 same substituent, you have to put them together in the name. Okay, so the last name octane looks good. For the substituent, we got methyl, but we got 2 of them. Whenever that's the case, we use di to tell us that it's 2 methyls. Okay, so this is dimethyl. And keep in mind, guys, there's actually no space. I'm just writing down separately so you guys can tell how they're spelled. So dimethyl octane. So what is this telling me? That I have got 8 carbons and then I've got 2 methyls. Okay, so 2 methyls. Now tell me, guys, what is left? What is, so you looked for the substituent. We already did that. What is the third step we are supposed to do? The third step is to number the substituent. We did that as well. We already know that the branch point should be 3 because both the methyls are sitting on 3. Now, guys, it might sound redundant right now, but the fact is that since we have 2 methyls, we are supposed to tell the location for both. Okay. Now, what we do here is that since both the methyls are sitting on number 3, we say, okay, 3, 3 dash dimethyl octane. What did we do here, guys? What we're trying to say is that we have 2 methyls. Okay, we understand that. We have 2 methyls. Both of them are sitting on position 3 and 3. Okay, both the carbons sitting on position 3 and 3. Guys, again, it might sound redundant, but we want to make it very clear that both the methyls are sitting on the same carbons, and it's not by mistake that we forgot to put one of the number. If you just say 3 dimethyl, then one might be thinking, okay, I've got 2 methyls, one is sitting on 3, where's the other one sitting? So we want to make it very obvious, very explicit, that both the carbons are sitting on 3 and 3. So 3 comma 3. Now, one thing to notice here is whenever you have a number and a name, you put a dash in between. So same thing here. Whenever you see a number and a name, you put the dash in between. But whenever you have two numbers together, you put a comma in between. So remember that, okay? So 3 comma 3. Of course, you don't want to leave that as 3 3 because that will sound like 33. So it's 3 comma 3 dash dimethyl octane. So guys, when you're going to be putting these on active, I think you will have to keep in mind that you will need these numbers. I mean, the commas and the dash. But I think it automatically takes them as you complete the quizzes. Okay, so that's one example. I want to give you one more example where we have something very similar, but we want to make sure that we understand this correctly. So let's say, guys, I've got a metal here, and then I've got another substituent here. So let's take a look at this now. Again, what is our first step? The first step is to find the longest chain. What is the longest chain? 1, 2, 3, 4, 5, 6, 7, 8. So guys, we didn't just find the longest chain, but at the same time we have numbered it. Let's see if our numbering looks right or not. Where are our substituents sitting? Because that's our step number 2. Where are the substituents? This is my substituent, and this is my substituent, right? So we got 8 carbons in the main chain, and we got 2 substituent. Both are 1 carbon and 1 carbon, just like this example. But if you compare and contrast these two examples, because they're very similar, but here both the metals were sitting on number 3. Here, one metal is sitting on number 3. The other metal is sitting on number 5. So that is what is different here, okay? Now, again, going back to the rules, first, longest chain, done. Second, look for the substituent, done. Third, number the substituents, or basically number the branch point, same thing, okay? So the substituent, they're getting 3 and 5 if I go from left to the right. If I go from right to the left, what do I get? If I go 1, 2, 3, 4, 5, 6, 7, 8. You see, the green side is losing because it's getting 4 and 6. The blue one is getting 3 and 5. So 4, 6 versus 3 and 5. 3, 5 is obviously better. If you're ever confused, add them together. 3 plus 5 is 8. 4 plus 6 is 10. So this side is a winner, okay? So blue wins. So that's why you're going to be keeping only the blue numbering. So we're going to get rid of all the green numbers. So guys, again, how do we actually put the name? Okay, so we got the rule how to set up the problem. How do we put the names? So first of all, I want to put the last name. What was the last name, guys? The last name is the parent name. This is again not a rule, but this is something we'll just keep you more organized in naming. So you got 8 carbons. I'm going to call that octane. 8 carbons octane, all single bonded, right? Now you have a metal and a metal. Again, the same thing. You got 2 metals. If I have 2 metals, I'm supposed to call them dimethyl. Okay, I'm not going to separate them out because they're sitting on 2 separate carbons. No, since it's 2 metals, I still need to call them dimethyl. But this time, you see the numbering will be different. Earlier, we had 3 and 3 for the last example. This time, it's 3 and 5. So what do? You just do simply 3 and 5. So 3 comma 5 dash dimethyl octane. Okay, so octane tells me I have 8 carbons, and then I have 2 metals. Each one is sitting on position number 3 and 5. Okay, now let me go back and show you the example we've done before. So guys, sometimes in the beginning when you're learning this, it might sound confusing that 2 carbons are dimethyl or 2 carbons are ethyl. So you need to understand here, I've said this before, when 2 carbons are attached like this, like continuous chain, okay, when your substituent is continuous, the carbon and then the second carbon, they're attached together, that's ethyl, okay? But when I have 2 carbons separately sitting, those are metals, those are 2 metals. That's not an ethyl, so don't confuse that, okay? Okay, now let's do some examples, guys, where, again, something similar, but something like this. So now let's take a look at this example. In this example, what are we supposed to do? Again, we go by the rules that we learned. The very first rule is that we need to find the longest chain. The longest chain is 1, 2, 3, 4, 5, 6, 7, and 8. So we got 8 carbons in the long chain. So similarly, we got so same thing. We got the octane. Now the idea is we need to number this, or we need to look at the substituents. What are the substituents, guys? Our substituent is this, again, just 1 carbon. And we have another substituent. This substituent is 2 carbons. So guys, what 2 substituents do we have this time? We have a methyl. And guys, what is this called? 2 carbons as a substituent is called? You can pause the video and tell me 2 carbons as a substituent should be called. It's called ethyl, right? So we got a methyl and an ethyl this time. Okay. Now let's take a look on how we are supposed to number this. So if I go from left to right, again, it gets 1, 2, it gets 3, 4, and then 5. If I was going from right to the left, this will be getting 1, 2, 3. It will be getting 4 and 6, just like last time. So 3, 5 is better than 4 and 6. So what do we do here? By the rules for the naming, you put the last name first. The last name is octane. What are the first name? The first name is methyl and ethyl. Now, how do we put them? Which one do we put first? Should we put methyl first, or should we put ethyl first? So the idea is you go by the alphabetical order. Okay, so ethyl versus methyl, what comes first? E comes before M, so ethyl should be written in the front. Okay, now if ethyl is written in the front, what number does ethyl get? Because we're supposed to tell what position we are on. We're in position number 5. So it's 5 ethyl. So the 5th position has the ethyl, 5 ethyl. And then we have the methyl. Where's methyl sitting? It's sitting on number 3. So we have the methyl. So we have the methyl. It is sitting on number 3. So whenever you put a number and a name, you need a dash. And then again, you see here, guys, we have a number, we have a name and a number, so you need a dash here as well. Okay, so this is all together. Okay, so 5th position has ethyl, 3rd position has methyl, and then you have the octane. Okay, I hope that makes sense, guys, here. Okay, now there's one more thing you guys need to remember, that when you're going alphabetical order, you look at the alphabet of the actual substituent. If I had 2 methyls here, like dimethyl, you're not looking at that di, you're not looking at that D. Don't put dimethyl in front of ethyl. Ethyl will still go first. You ignore this D in dimethyl. You have to ignore this D when it comes to putting things in order, in alphabetical order. Okay, still ethyl will go before dimethyl if you ever see that kind of example. Okay, all right. Okay, so I believe that should be it for naming the alkane molecules. Okay, so I'm going to end this video here.